What ordered pairs make the following expression false? Looking at this Boolean algebra expression that uses notation where the wavy line tilde is a not symbol, the plus symbol is the OR operation in Boolean algebra, and multiplication, for example, A times B there written together, is multiplication, and that is representative of the AND operation. Well, the easiest way to tell what ordered pairs for A and B that make this whole expression false would be to plug in all the possible ordered pairs for A and B. When you have two variables A and B, the A could be true or false, and the B could be true or false. But the A could be false when the B is true, or the A could be true when the B is false. So there are four possible ordered pairs that we could have to consider and plug into this full expression to see if it simplifies to true or false. And of course, you know that 1 is often our shortened way of representing true in Boolean algebra, and a 0 is sometimes used to mean false. Okay, well, let's plug these ordered pairs in to this expression. So the first scenario is both variables A and B are false. So rewriting all of that original expression, the not of false times in parentheses of false plus the not of false times B. So I'm going to use a little asterisk here to show that there's multiplication going on there. And then that plus symbol followed by a 0 for that B. A times B would be 0 times 0 in that set of parentheses. That plus, of course, translates to a plus. And the not of A would be, I could write it as the not of 0, the not of false. Okay, so all of that expression is equal to this. I'm going to go a step further and simplify parts of it. The opposite of false is true, so that's represented by a 1. I have 0 plus the opposite of that 0 is a 1. Rewriting times 0 plus 0 times, okay, I can do this math. 0 times 0 is a 0 plus, and I'll simplify this. The opposite of false is true, and a parenthesis. The next step that I could do in simplification of all this, 1 times the set of parentheses, 0 plus, well, 1 times 0 is 0. And over here, I can simplify the 0 plus 1 is simply a 1. Okay, the next step, that 0 plus 0 in the parentheses is really 0. I still have a 1 here that's still being multiplied with that 0. Rewriting the plus, hey, 0 times 1 is 0. And the next step, this 1 times 0 is 0 plus 0. So that all simplifies to 0. So yes, that is one situation where all of this simplifies to false if we plug in 0 and 0. So now I plug in the next 0 and 1 into this expression, and now I simply have everywhere that I had a B, I now have a 1. Now I could rewrite all this, but since I have a different color marker, this B here is really a 1. I'm just going to scribble over that and make that a 1. This B is really now a 1. This B is a 1. Everything else was a blue 0. It changes this next step only in that 0 is a 1, that's a 1. And 0 times 1 is the same as 0 times 0. It's still 0. So nothing else changed. 1 times 1 is now 1 instead of that 0. And this is just rewritten as a 1. This 0 plus 1 is now a 1 instead of a 0. And 1 times 1 is 1. 1 times 1 here is 1, plus 1. Uh-oh, that particular step, that substitution, worked out to be true. So 0, 1 is not one of the ordered pairs that make the original expression false. Okay, on my next step, I'm going to use the color black. And this time I'm going to plug in a 1 and a 0 in that order. So I'm just going to do it right above the problem, plugging 1s in for all of the A terms, plugging a 0 in for the B's, and simplifying. I'm going to do this one much quicker. 1, the opposite of 1 here is a 0. 0 times that 0 simplifies to 0. 1 plus 0 is 1. And the opposite of 1 is a 0. And that 0 times that 1 is 0. So this whole left side of the plus is 0. Over here, looking at the black substitutions. 1 times 0 is 0. The opposite of 1 is 0. 0 plus 0 is 0. And 0 times this 0 is 0. And finally, 0 plus that 0 is 0, which is what we want if we care about all of this evaluating to false. So that is one of the solutions. And I only have one more of my original 4 ordered pairs to check. And let's plug in a 1 and a 1. I'll use, say, the color purple here. Now, if we're plugging 1s in, a 1, the opposite of this 1 here is a 0. 0 times anything is 0. And this 1 plus 0 is, well, inside the parentheses there, I have a 1. The opposite of this 1 is a 0. And 0 times that 1 is all 0. So this left side is all 0. Plugging in 1s for the A and B over here. 1 times 1 is 1. The opposite of 1 is 0. And 1 plus 0 is 1. And that 1 times that 1 is 1. Well, that 0 plus that final 1 on the right-hand side is an overall 1, which is not false. So this is not an ordered pair that satisfies the exercise. So the answer is simply 0, 0 as one of the ordered pairs, and the ordered pair 1, 0. And those are both solutions that make the original expression false. And that's what my answer would be to this exercise, those two. There are other ways to have done this problem. Instead of plugging in the 4 ordered pairs, we could have simplified that original expression using identities of Boolean algebra. And we still would have had to have plugged in the 4 possible ordered pairs, but we could have simplified this. I'll do it real quickly. The knot of A times A using the distributive identity. The knot of A times this term would look something like this. Plus B times AB would look something like this. Plus that B times that knot A would look something like this. And these would turn out to be 0 because of one of the identities. This would turn out to be just simply AB instead of 2 B's there. And this term would simplify to just not AB. Looking at this whole thing, this is nothing. And I could factor out a B here. Rewriting this here on the right. The opposite of something plus itself is always going to be a 1. 1 times B would be B. And I could factor out this B here. writing my steps over here, b times 1 plus not a. So all of this turned into this over here. 1 plus anything is 1. And I'm left with just b. So that original expression is the same thing as just b. And remember, we want false here. We don't want true. So it turns out any one of the 4 ordered pairs in which b was false is a correct solution to this exercise. So that would have been another way to have ruled out these two and left these as the answers.